Very good morning to one and all present here. I'm Manisha, Assistant Professor, Department of CSE, RMDEC Engineering College. I'm going to explain about microcontroller and embedded system subjects under that Unit 4, Embedded System Design Process. So, embedded system design process, design methodology, a procedure for designing a system. It understanding your methodology helps you to ensure compile a software engineering tools, computer aided design, CAD tools can be used. Help automate methodology steps, keep track of methodology steps. So in embedded design, how it should be, show yes, sure, no, should it. So if it is should it, how no, no problem. If it is yes, what is the problem? And if it is yes, should it? And again, yes, if it is no problem. If it is no, what is the solution for that? So this engineering. So levels of design abstraction will be having some specification, requirements, specification, architecture, component design, system integration. So if it is requirements, what does the customer wants? If it is specifications, system functions and characteristics. So architecture will have the abstraction of a block diagram. Component design will have hardware and software module detailed design. System integration will be having working abstraction. So it follows two approaches, top-down approach and bottom-up approach. If it is having a top-down approach, start from the most abstraction description, work to most detail. Bottom-up design, workflow, small components to big system. Real design often uses both techniques. So stepwise refinement at each level of abstraction, we must analyze the design to determine characteristics of the current state of the design, refine the design to add detail. So comparing to the embedded system design constraints, we are categorized into cost, performance, size and weight limits, power and energy limits, environment. So if it is compared to cost, how the market value personalized, which don't deliver the adequate value for the cost, performance required operations, meet real-time deadlines, mobile aviation, automobile, automotive and system, power and energy limits, battery capacity, cooling limits, environment temperature may range from -Celsius and even more. So microcontrollers, programming language, what operating system, what is the project cost. So how the project cost is determined, non-recurring engineering plus recurring engineering with number of units. So non-recurring includes design time, tools and facilities. Recurring engineering requires components, manufacturing. So if we conclude non-recurring, so it is a general one. How much design time when we are designing will be having, and then what is the tools and facilities will be fixing. But components, it is not with how many units components you want, how many testing you want, how many manufacturing people you want. So that is so that it will be multiplied. So this will be a project cost. Thank you.